Excellent. Good afternoon, everyone on the call, and good evening for people joining from different time zones. And um, my name's Johan Swanepoel. I'm the Principal Solution Architect for Red Hat, looking after the health portfolio and specifically federal government organizations. And I have the joy of having Ben Cushing with me today, who's our Chief Architect and Strategist in the Health and Life Sciences portfolio as well. So Ben, if you wouldn't mind doing a quick introduction, but just to also reiterate to the audience, we are talking about how we can help drive open standards and use data more effectively in healthcare. And there's some trending topics in that at the moment that we'll sort of talk about how to do that safely and share real world examples of where we're doing that.
Yeah, hi. I'm Ben Cushing, Chief Architect, Health and Life Sciences. I'm in the office of the CTO at Red Hat. I spent about 6 years at the National Institutes of Health in the United States. I was responsible for several major programs at the Department of Veteran Affairs. Spent a few years supporting Johns Hopkins, all prior to joining Red Hat, where I've worked on a bunch of crazy projects that I'll probably end up talking about in the next hour.
Excellent. Yeah, we will be looking at the Q&A as well. There's some time at the end for Q&A, but if there's something really interesting that pops up in the meantime, we might interject into the conversation as well. I guess, Ben, you've alluded to some of the work you've done with Veteran Affairs. There's things like Mission Daybreak and suicide prevention and all those sort of things that we've done. But I'd like to hear from you what sort of stands out in terms of impact and how the technology was applied and open standards and open source have come into play in that.
Yeah, I would say the first one I would touch on is definitely VA arches. So the VA, so this is the U.S. Department of Veteran Affairs. They face not a unique circumstance where they have a lot of data for U.S. veterans that they want to do research on, but they can't actually share that data externally from the agency, right? All the privacy laws you might imagine are just piled on top of that desire. So what they did was they created a environment called VA Arches, where they could actually bring extramural and intramural researchers together to actually work on synthetic patient data. And this was all done in the open source, with open source tooling in the open source community. And a lot of those tools were actually the beginnings of what we now call OpenShift AI. So like a lot of the upstream tooling that we use now as part of our product set was actually, came from that activity. And VA still uses VA Arches today. So it's still a very active part of the research that goes on at VA. They use something like 22 million patient records that have been essentially rebuilt into synthetic records, which are then available through the actual platform. And then, researchers from all around the world can then gain access to that, create insight, and share that insight back to the VA community to affect veterans' lives, and then also share those insights out into the larger healthcare ecosystem, and see what impact they might have internationally.
Cool. Yeah, interesting in terms of sharing and using the data and then taking the research and the learnings out. And when I presented at Digital Health Festival, which is kind of interesting, a lot of that was how we use data and what we can do to make the clinicians' lives easier. And a lot of it is sort of looking at, and there's been advice from the Royal Australian College of GPs that's come out last week, which is really interesting as well in terms of using AI in particular. And you mentioned that and how we apply that to outcomes, but also in a way, obviously always conscious in a way that we do it so we don't add a burden to the care provider. And then adopting standards like FHIR comes into play, which is something different and new that people have to look through and sort of go through and work through those sort of things. I guess, again, what have you seen and what have you been involved in sort of looking at how to use those standards to help drive care practice? And I think one of the things you I know you're involved in is the sort of BPM plus health projects and stuff as well. What does
Yeah,
that
I
sort of
can.
look like in your world?
Well, so the first thing that comes to mind, honestly, is another VA project. Just going through a series of things. The first is the VA recently had a tech sprint for ambient dictation. So what that means is there's, in the room between the patient and the provider, there's a microphone, and it's capturing the dialogue that's going on in the room. So the idea being that the clinician should not be sitting at their computer typing away or interacting with the electronic health record. They should be really interacting with the patient. And um, and so it's essentially just creating a transcript. Now, this is not a new idea, right? Like this has been around for a while. What happens next is actually the real innovation, which is not only is it capturing the transcript, but it's also extracting the concepts from the transcript. So, maybe there's a lab that was called out, a condition that was called out, some sort of intervention that the clinician wants to see happen. And those are automatically coded. So you might see, an RX norm code applied to a particular intervention. You might see a SNOMED code connected to a particular condition. And all of those data entries are essentially put into like a draft format uh, and ready for entry into the electronic health record. So you might have a data entry person that comes in after the fact to review that content and then promote that into the health record. In addition to that, the endeavor also is to generate clinical notes. So instead of having the clinician spend hours out of their day going through all of the patients they've seen that day and write clinical notes about those encounters, um, the the large language models that are deployed in this system are able to produce the clinical note for the clinician, who then reviews the clinical note for accuracy and anything else they want to edit, and then they're able to promote that clinical note into the electronic health record, so saving them just tons of time, really. And then the last part is the large language model is capable of producing a summary discharge note. So that would be for the patient, and was I think is the most impactful, frankly, because most summary notes that are given to patients are one size fits all. It's just a summary that was developed over time. It doesn't really account for your education. It doesn't account for your primary language. It doesn't account for your background or anything like that. So the idea here is that the LLM is producing this summary note for you as an individual. It's a form of uh, personalized care in that it can reflect your education level, it can reflect your background, your primary language, and so on, and provide that vital information in a way that is going to be the most digestible for you as an individual. I think that program within the VA is really, really incredible. They just wrapped it up, the tech sprint, a few months ago. A lot of, I talked about VA Arches already. VA Arches was kind of a part of making all this happen as a platform. So it's something, really proud of. Um, and then moving out from that, into the HL7 community and in the fire community. One of the things that's happened more recently is the BPM Plus Health organization, which is a international community effort to automate healthcare, was moved into HL7 as a new working group. So for those who, I'm sure everyone here is familiar with HL7, it's the international standards body responsible for, V1, V2, V3, CDAs, fire, et cetera, et cetera. They make lots of standards. Well, what was been going on since about 2014, a collection of organizations, so like the VA, the Mayo Clinic, Red Hat, Intermountain Healthcare, bunch of medical societies, they all got together and started to look at how can we automate healthcare and how can we model care delivery. And what they did was, I should say we, because I was involved in this, we looked at what other industries do. So inside of finance and manufacturing and supply chain, they had embraced BPMN, CMMN, and DMN as standards for process automation. And they have applied those in those industries. Now, what we were capable of doing within this group was taking those standards from the object management group and creating a field guide for how to apply these for healthcare. And since then, Intermountain Healthcare, the Mayo Clinic, and the VA have all been piloting this level of automation. And since then, again, this organization has essentially moved into HL7. Now it's part of the HL7 standards body. So anyone here who already participates in HL7, you can go find that working group. You'll see my particular working group, which I chair the process automation and enablement working group. And I'd love to see anyone there. And what we generally talk about there is how to take clinical best practice guidelines and clinical pathways and model them in these process standards, and then how to deploy those standards as process instances, meaning that they have stateful. It's a really IT term, sorry. They're, become stateful processes that can control tasks. So they can distribute tasks to a clinician. They can distribute tasks to another system, and those tasks are how things get executed and how you orchestrate care. One of the biggest problems we have in healthcare when it comes to quality uh, and high reliability is that the care itself is inconsistent. So when we start to model it this way, we can actually bring a level of consistency and quality to the actual care that gets delivered. In addition to that, it produces like an audit trail, so we can actually see what care was delivered to the individual. We can also do scientific improvement. So, if we have a model, we want to improve it, we can tweak some part of the model and we can see if those outcomes are better or not. And then we can go with that other variant and produce better outcomes. Anyways, this is how we generally get to a learning health system. So everything I talked about today, the ultimate goal is to create a learning health system, which we just don't have right now. And I think I think if we can do that in any place in the world, I think we're going to see the most dramatic improvements in healthcare delivery.
Cool. Yeah, there's a lot to unpack in that answer, right? And a lot of acronyms and a lot of things that when we talk to clinicians, might create a sense of, well, I've got to learn all these new things. And the same with the RACGP guidelines talk about, yes, there's wonderful things you can do with AI, but there's training, there's enablement, there's and in that model, how do you sort of introduce these benefits without creating another set of tools and screens and clicks and things for the clinician to work through?
And fear too, right?
Yeah.
How do you create, trust, reduce fear, and reduce burden, right? Yeah, I mean the operating principle generally that I encourage everyone to follow is think about the modality of how the system will deliver any sort of recommendation to a clinician, a patient, a payer, whoever might be involved in the system. The best thing you can do, of course, is to use the modalities that already exist. So, we were talking about Smart on Fire, right? Smart on Fire is a really great way to reduce modalities because, most electronic health records now have a way to incorporate Smart on Fire applications directly into the electronic health record. That's a huge boon, right? It means that the clinician can stay within the EHR. They don't have to go to a different system. They don't have to leave their environment. They can just open up the application within the EHR, pick up the patient context, and then continue onward. So I actually believe this is how we're going to see more and more AI systems get involved in the electronic health record, not necessarily directly through, Epic or Cerner or Allscripts or whatever, right? It's more likely that these early movers are going to come through as Smart on Fire applications, largely because the industry is moving faster than the electronic health record companies are moving. So that I think that's really where we're going to see the innovation, and Fire plays a major role in that. Just being able to maintain that context, between the EHR and the application, and provide a common exchange between those systems. It's going to be really, really critical. I think when it comes to trust, the I know that there's probably a lot of government folks on here, so let me see if I can say this like appropriately. And I've been working with federal governments most of my career, so I understand. I'm going to say this with love, but generally the population trusts the clinicians before they trust the government. So I think ultimately trust will be something that gets extended from first with the clinician feeling comfortable and understanding the system that they're using. And that same level of trust will extend ultimately to the clinicians, or sorry, to the patients from the clinician. For government, it's sort of you want the patients to trust that you have their best intentions. You probably do, and but they're it's sort of an ingrained a sense of mistrust, and so it's really important that the providers feel like the system they're working with is going to really have an impact. And another example of this I can give is nobody that I know really anymore questions the value of like Google Maps, right? Like at least in the States, we use them. We use it. Everyone uses it every day, all day long, right? Google is literally tracking our every movement, right? They're tracking where we went from the house to the store and back again, and we're comfortable with that. And so you got to ask yourself, why? Why are people so comfortable with that? And I think the answer is that it's valuable. Google Maps is probably one of the most valuable applications ever made, right? I can get in my car, drive to a place I've never been to before in my life, know how to get there, and know how to navigate around that place for the first time, and I don't have to do anything besides follow the direction, right? That's wildly valuable, and because of that, I have overcome my mistrust of Google specifically because they're giving me something so valuable. I think in healthcare, we need to have that level of thinking that when we start building AI tools, they have to be wildly valuable to the clinician. And once they are, then the clinician will begin to use them, begin to understand how valuable they are, and begin to build a relationship with the application and the system that makes it. Now, obviously, like things like security and privacy and all those things have to be at the forefront and dealt with for sure. But we're not talking about like, objective realities. When we talk about trust, we're really talking about subjective realities for the clinicians. And this is how we start to overcome that distrust. And I think ultimately the provider's feeling of trust will extend to the patient because they'll make the recommendation to the patient. They'll look at the options they can provide their patient. They'll pick the one that they're comfortable with and say, hey, you should really try this application. It's worked really well for my patients before. I've had good results. Maybe it's like a journaling application for behavioral health, right? For a patient to track their substance abuse, something like that. And then a clinician will say, this is something I've learned to trust. My patients use it. Maybe I use it. And then, they'll extend that to the patient. And then sure enough, like that's where the trust creeps into the system.
That's great. It's an awesome comment in the chat that Google Maps comes out of Sydney originally, which is great too. So it's a very good example. I think, yeah, and if anyone, like a lot of the work that I do is with the Australian Digital Health Agency and My Health Record and all those sort of things. And when I go to the GP for my annual checkups, or I would just ask him that question, right? What is it? How do they feel about it? And I think you're spot on in terms of trust, engaging the GPs, and they advise the patients. And we sort of got around some of that specifically to My Health Record by using an opt-out model, changing from opt-in, and using that sort of nudge theory that's helped. The other thing that comes to mind is many years ago, we were doing work with Apple, and they said the biggest thing they did for security adoption was when they introduced the sort of thumbprint biometric scanner. So essentially making it easy and seamless to use a technology, and that really increased compliance. And where that relates to this, when I presented at Digital Health Festival off the back of some of the work that you've done in the US, was when I showed how a clinician could interact with patient data and historical data in a natural way. So using chat, using that sort of, they didn't have to learn new query languages or a complex interface. That really resonated with the clinicians at the talk. And it's like, okay, hang on, this is something that looks like it's going to make my life easier. And there's been some of the work that's been done in that is really gets people thinking about using FHIR as a standard to do those sort of things with the data being really rich. But I think it's worth you sort of talking and elaborating a little bit about that. And I'm keen to sort of just add another layer to that, because when I talk to technologists about that, they're like, oh, hang on, I don't want to actually put my data in a machine learning model. And we really have to take a step back and go, well, the model's not training on your data. It's not getting in there. It's not doing those sort of things.
Yeah, this is a bit of a history event for me, because back in 2017, I was doing some work with Johns Hopkins, and I had used FHIR before on a VA project, and I was still really interested. It was like, I thought version 1 dot something, or super early, and I was looking at the data, and I realized, you know what, FHIR data is actually a graph. Like, it can be represented as a graph. And this is just an idea. Probably came from, I have a colleague, Dr. Shane McNamee, who probably put the bug in my ear, because he's also like just always throwing like wild ideas out there. And I tried it. I like took the FHIR model in a synthetic patient record, and I flattened it, and I brought it into a graph database. And so, just, I'm not going to get technical here, but like, it creates a visual graphical representation of the record itself. So you see a condition here, and its relationship to an observation, and its relationship to an intervention, and intervention's relationship to the procedure, and the procedure's relation to the facility, and so on. And you can actually see all that, right, for a single patient. And then you can see like 10 other patients, and you can see how they actually relate, the patients, to each other. It's a really powerful way to view FHIR data. And I built that up, and I showed the innovators at Johns Hopkins, and they were like, that is amazing. And I was like, I know, right? And they're like, well, what do you do with that? I was like, I have no idea. I don't know why this is helpful. Like, I think it's really cool. I don't know why this is useful yet. Fast forward to early last year. I was talking with a colleague of mine, Sam Schiffman, in Toronto, at the Smile Digital Health Summit. And we were chatting about graph databases and FHIR, and I talked about that work, and he was like, light bulb, right? And the thing that got his wheels spinning was, what if we use that for RAG? So RAG is retrieval augmented generation. Okay, it's a technique that you can use to augment a large language model. So if anyone here has used like ChatGPT, or probably everyone has, but there's also, there's lots of open source large language models out there, you can pull down locally and work with. And RAG is a technique for essentially providing information in real time to the large language model to supplement it, so that when it answers a question, it's actually drawing on knowledge that it's been retrieved. Now, most RAG systems use vector databases, meaning they have, it's like vectors are generally just databases with lots of coordinates for concepts that are clustered together. So you might have like, all of the concepts of different kinds of fruit would be clustered in one area, like apples and bananas and pears are all fruits, and they're all going to be up here in the left. And trains and cars and automobiles would be on the bottom right. And then they get coordinates, and it's all just a bunch of coordinates, essentially. That's what a vector database looks like. In a graph database, you would actually have, those fruits related to each other because they're actually fruit. And you'd have, the automobiles and planes and trains all connected to each other because they're all vehicles, right? And they get clustered graphically, meaning there's a node that says vehicle, and then you have different kinds of vehicles that are connected to it. And when we started to bring those two things together and then use RAG, we saw some wild things occurred. So first off, we took a large language model. Okay, we tried this with Mistral, Llama, and GPT, and we essentially used a RAG system with a graph database with FHIR data in it. Okay, and then we asked basic questions about the patient, and the results of that were like ridiculously accurate. I mean, like we had a hard time finding problems with the results, largely because the content that was coming back from the graph database was fully weighted, meaning that the LLM was not allowed to reinterpret the content. It was only able to interpret how the content is put together into a paragraph response. So in that way, the LLM is acting more as an API to the human being, to the database. So Johan, you already hit on it when you said, how do we abstract away the complexity of an EHR's, UI? How do we abstract away the query languages like, CQL and other things that are very useful, but like really hard to learn? This is how we do it, right? We use a large language model as an API. You go into your prompt and you say, hey, my patient is having seizures. I can't, are they on gabapentin? And then you'll get an answer. Yes, they were prescribed gabapentin 5 years ago. This is the information about the gabapentin. Here's the clinician who gave it to them. Here's the facility where they received it. The actual medication was prescribed in relation to seizures that they had 7 years ago. All of the information you got back from the graph is uh, actually like, I think we can actually set this, but like, usually it's like 2 standard deviations from the concept that you looked for. So in this case, I mentioned gabapentin as a medication, or I mentioned seizures, right? So like 2 standard deviations from seizures, that content would be retrieved, restructured into a paragraph for somebody to consume. And it's easily consumed. I mean, and like I mentioned before about individualization of the response, we can also send the data back based on the clinician's experience. If they're a specialist, we can give them a highly specialized response. If the question's related to neurology and they're a neurologist, we need to give them a very, very concise, accurate answer. If they're a generalist and they're asking a neurology question, then we need to give them something a little bit more consumable, with less jargon and less assumptions about their experience. And that can happen, right? Those are things you can cue the LLM to do. So anyways, that's where very recently, I've been able to get involved in like the integration of FHIR as a standard with AI and actually see real results. And I'll say that there's a number of organizations already marching forward with this concept, because it has huge implications towards building a learning health system. So going back to that idea from before, one of the biggest challenges that our clinicians face is the growth of knowledge. Okay, like in the clinical space, knowledge doubles every 3 months. Okay, and there's no clinician on the planet who's got a big enough brain to memorize all that stuff. Like, let alone the fact that it's doubling every couple months. So how do we help with that, right? How do we keep ahead of that growth? The idea here is to put that kind of knowledge into a graph database and then use an LLM as an API to access that knowledge and augment the human being. And coming back to your point about training and tuning models and like not wanting your data being part of those models, this is one of the ways you do it, because nowhere in my description did I say that we trained or tuned a model. In fact, all we did was take a existing model that had been trained on something else, and we used it strictly for its natural language processing capabilities. We didn't use it for its knowledge. That's the biggest difference in this kind of setup. I think it's really important to understand the difference between a RAG LLM system and a pure LLM system. In a pure LLM system, you are reliant on that LLM being trained or tuned on the clinical data and clinical knowledge at a regular cadence. In the RAG LLM system, you don't have to do that. All you're doing is updating the actual database with that knowledge, and then the LLM is being in real time being augmented by that knowledge. This also saves a ton of money, right? Like if I was going to tune and train a model on clinical data or knowledge itself as it's coming out from different institutions, medical societies, et cetera, I'd be running training cycles every other day, which is a wildly expensive activity. And you just don't have to do that in this case I'm describing with using the retrieval augmented generation. Another advantage there is because we're not using a service, we're actually able to deploy a GraphRag LLM to a secure enclave. So it could run on-prem. It can run within the confines of a private cloud. It can run on a local desktop, which we've done that too, you know. And you don't have to send your prompts to OpenAI, Microsoft, whoever, right? And run the risk of data leakage. Let me define that real quick. So data leakage is bidirectional. So the first part is that the LLM that you're using has potentially data that's part of it that it's unaccounted for. So like let's say it's maybe like a clinical best practice guideline from 10 years ago, that is wildly inaccurate now, is part of the LLM that you're talking to. You don't want that clinical best practice guideline to inform you of anything because it's wrong, but it's part of the LLM's training set. So that's one form of data leakage. The other one is, if a clinician were to accidentally put patient information in the prompt, that information goes up to the service, the OpenAI service in the case of ChatGPT, and it doesn't, not only does it expose OpenAI to litigation, it also that prompt becomes part of the next training cycle. So now the patient's data is inadvertently part of the LLM itself, and that's a huge no-no. And I understand why clinicians want to do that, because in order to keep up with this growth of knowledge, they have to do this kind of work. But I think they can do that, but they have to do it safely. And what I'm describing is a way to do just that.
Yeah, no, I agree. I think the key there is, to your point, we're not training the model on the patient data. We're not burning down basically the rainforest to do that, and it's cost efficient. But
yeah.
Also, just with that model, you don't have to re-architect your systems, wildly re-architect your systems. You don't have to. It's basically looking at your existing data formats, data standards, and bringing it, using that retrieval augmentation to bring that in, a retrieval part, and then transforming or summarizing information in that way. And it was interesting.
Just to add that the database also becomes your IP, right? It's actually your knowledge that's stored in the database. It's not, the LLM is not your IP. And the other advantage too is you can swap the LLM out. If there's a new LLM that comes out in 3-4 months, fine. Take the one you're using now, put in the best one. And just keep updating the LLM with the newest and greatest. Meanwhile, the static, or I shouldn't say static, I should say the stable data that you're reliant on, the patient records, the knowledge base, et cetera, that's in your database and you control it.
Yeah, exactly. And that ties into, there's a comment in the chat around AI and ethical review within healthcare, and patient standards and rights, and all of that stuff is really, really valid and valuable to look at and co-design with the involved professionals, right? I think to your point, using a model where the AI is not doing healthcare things per se. All it is doing is it's the API between the human and the technical bits and pieces and the data. I think I like that sort of description. It makes it easier for us to access and use the data, which helps reduce some of the concerns around biases in models and all those sort of things, because we're not using the model on faulty data or trained data or data with biases in it. It is the patient's healthcare data that we're just saying, well, just summarize this for me, or tell me in this data, do you see this thing? Or based on the practice guideline and what we've seen, what sort of the recommended actions next, which makes it really powerful working in that
Yeah,
way.
one of the other areas that I'm working on with the Centers for, the CMS. So, it's essentially the largest government payer in the United States, is translating data from one type to another using a similar scheme. So, one of the challenges we face in healthcare is interoperability, right? So we've been talking a lot about like human or orchestration, but we still have the very real problem of interoperability between systems, right? So like one system might share data as CDA, but we actually need it as FHIR. How do we, how do we automate that process? Now, there's a lot of like great companies out there that will come in and they'll do manual matching of data fields, essentially create point-to-point data marshaling between CDA to FHIR, and that works, but it's pretty brittle. One thing changes in the CDA format, the FHIR output that you get breaks, or you decide to move to a new FHIR format. You're on version release 4 and you want to move to version release 5, right? Now you got to redo all those mappings. So one of the things I'm really interested in now is why don't we try this with LLMs and with graph databases? So again, like we are putting the schema of these particular data formats, so the schema for FHIR, the schema for CDA, into the graph database itself, and then asking the large language model to rewrite the data. So its job is not to interpret the data. Its job is not to like really understand the semantics so much as to reformat it into the actual type that we need. So in this case, CDA to FHIR. So that's where my research is going right now, and like I said, I'm working with CMS on that. Largely because at least in the States, they're dealing with I think it's something like 4 million payment transactions a day, and a lot of the providers that are asking for payment, they have to adhere to the CMS API for these claims, and the API is difficult to understand. It changes a lot. And the providers are not sophisticated enough to keep up. So, my point in this is to say, well, why should they have to, right? They should be able to submit their claim. We should have an interpretation layer that interprets their claim, reconstitutes it in the format that CMS expects it to be in. The claim is processed, and then payment is executed based on what the payer decides is appropriate. I think in that way, we actually remove a lot of the complexity from the system. We actually let providers focus more on caregiving and less on, doing their bookkeeping and keeping up with the API requirements and so on, so that they can get paid. I think in general that's pretty universal problem actually. So if we're successful with that with CMS, I think that could go a lot of different places across the world.
Yeah, definitely keeping a close eye on that, because I know a few people that are very interested in that sort of capabilities. So there's a comment in the chat that I'm sort of going to interpret, because it aligns to, I think, where we want to take some of the conversation, and that's, part of it talks about digital literacy and digital divide and how we help almost from the ground up, embed that in the system and who can access. And to me, that talks a lot about trust in the system and how we build trust. And I guess there's a government role there. I'm not sure exactly what you've seen in that sort of sense, but also an industry role. If I think about the airline industry, they treat traveler safety as an industry problem. So if something goes wrong with Boeing, that information gets shared with everyone, airlines, Airbus, everyone, and it all.
We hope.
Yeah, yeah, that's the
Sorry,
word on the
keep going.
street.
Yeah.
But I guess the question would be, what does that look like in a healthcare sense? And you talk about a learning health system. So it's a big question around sort of trust. There's a lot there in terms of enabling the ecosystem and the people at the coalface. But there's simple things that we've heard with my health record as an example. I get my pathology reports before the doctor looks at it, and creates a whole different set of problems. But I guess your thoughts on where and what you've seen and how people have done it well. I obviously think open source plays a big part in building that trust and helping people understand that. And there's a bit of conjecture about what open source means in AI. Mark Zuckerberg has a very different definition to the purists because he comes from a commercial world as well. But
yeah, and it just just to put a point on that, like Llama as the AI, the LLM that Meta and Facebook has put out. It's a great model, but yeah, it's not truly open source. It has, like, the licensing is very it's very permissive if you are just doing work by yourself, or you're building for a small system. But as soon as it starts to scale, then the open source kind of falls away. The license is odd in that regard. I highly I'm not saying that you shouldn't use an LLM like that. Just be very aware of the language around any of the models that you might pick up and start working with, especially as you think about scale. So there are a lot of pure open source tools out there, and it's important that you go past the marketing and look at the actual license, and you'll see pretty quickly what they mean. So I think for the first part of your question, I wanted to tell another history lesson here. So I'm not really sure when the Industrial Revolution hit in Australia, but I can tell you when it hit in the States. And it's actually related to something that happened in the railroad industry. So for a really long time in the States, we had railroads of many different gauges across the whole country. Okay. And the gauges are, generally the distance between the rails and the width of those rails. Okay. And so what would happen is, if you had a train and you wanted to go across the country, you had to make like 10 stops across the country. Your train had to get lifted up, moved over, your wheels had to get changed, and you were dropped down on another track, and then you'd go forward and you go to the end of that line, you get lifted up, your wheels would get replaced, and you get dropped onto another gauge, and you continue onward. As you might imagine, this did not work well. Right? It was like wildly inefficient. At a certain point, the federal government, the United States, said, we are going to have one gauge. And that single gauge, when it was actually implemented, triggered the Industrial Revolution in the United States. Because now we could just move goods. We didn't have to do all that. We could just say this train is going to go from here to here. Now, the reason why I bring this up, if you haven't picked up on the metaphor already, is this is what's happening in healthcare. We're actually at a point where this healthcare revolution is starting, and it's because of standards like FHIR, because of standards like BPMN, CMN that I mentioned before for process. These standards are going to allow us to move data, move process, move semantics between organizations without having all these multiple steps. And it's going to allow us to actually smooth out the care continuum as well for patients who are moving between different systems. So like even in Australia, where there's a national healthcare system, you guys have the same problem everyone has of you got multiple instances of an EHR, meaning that there's, for each patient, there might be 10 different records for that patient. So you don't really have a longitudinal view of that patient. This is how we begin to pull down those barriers and actually begin to have longitudinal patient records because of those standards. And I think what we're going to see is a revolution. I mean, in the healthcare space, and it's kind of when you're in the beginning of something like this, it's hard to really believe that that's going to happen. But if history plays out the way that it has in other industries, I think that the tells are all there.
Yeah, no, it's good. The technology is there. I think the policy is aligning to that in Australia, which is really, really exciting. So there's a question from Pierre, open source trust comment, and somehow related to Facebook definition open. Yep. The question would be, to what extent is the Australian and American institutional governmental landscapes differ when it comes to infrastructure, sovereignty, and monopoly of Microsoft? That's an interesting sort of question.
I can try to address that.
Mm.
So data sovereignty, huge issue. I especially I live in the States, so I have probably more of a US mindset, and most of the companies you're talking about, Microsoft being one of them, are based in the United States. So for the most part, when these American companies are holding on to American citizen data, it's like we don't worry about it as much. I definitely empathize with folks who are not from the United States. When one of these large companies has your data, that must be unnerving, and I think I can understand why. One of the things that I'm involved in, and Red Hat, is federated learning, and the idea behind this is that we should be able to train models, AI models in particular, against data sets and maintain data sovereignty. Okay, so the way this works is, I'll give you an example of like the UN. Okay, so this is actually a real example, by the way. So the UN is trying to create AI models for climate change. It's really difficult because the United States has their climate data, and Russia has their climate data, and Australia has their climate data, and China has their climate data. And it's very difficult to have everyone exchange that data. They don't want to because a lot of the data represents national secrets. There's all kinds of, just bad vibes across the board. So the idea here is, instead of exchanging the data, we're actually distributing AI models. And each nation state is training the AI model against their data set and then sharing the AI model back to the UN. And then the UN distributes the model again. And they create a life cycle of that model going back into the individual nation states. And in that way, all the contributors benefit because the model they keep receiving from the UN is better and better and better and better. But at no point was their sovereign data exposed. I think that for healthcare is going to really, really accelerate the AI model training that's going to happen. But just at least in the United States, we had, during the pandemic, we had a huge issue with the states. The actual US states would not share their data with the federal government. It actually took an executive order to force the states to share their data. And it took a while, like for the first, I don't know, 6 months of the pandemic, we didn't have a population health view of COVID across the entire country, which is absurd. So the CDC, specifically the Center for Forecasting and Analytics, is engaged in building up federated learning capabilities so that they can distribute models to the states. The states can train with their patient data for their citizens, and then again share that model back up to the Center for Forecasting and Analytics, and then they can have more advanced models, and they can actually use those models to predict where the next epidemic might occur, And then in the case of an epidemic, actually do modeling for what the disease outbreak might be by geography, and then apply the proper interventions that are necessary to reduce the uh, expansion and further infection of the actual disease state.
Yeah, I agree. I think it's really good. I think the one comment I would add to that also is definitely not just a Red Hat view, but the view in the communities that we work in terms of AI and models is like transparency in terms of where the data comes from, having the ability to run the models where you want to run them, not necessarily being beholden to a large multinational. All of those sort of things are really, really important. And providing the tools to the community to actually train the models, have the transparency of where the data has come from, and being able to bring those weights into the models is the stuff that we're working on. And I think for healthcare, it's really, well, extremely important, not just in terms of running models at the edge, but when, I mean, the next question talks to that as well, in terms of having that UN climate change model in healthcare extending to individual data ownership and self-sovereignty and those sort of things, which is, I think that's another whole topic in and of itself.
Well,
About, yeah,
I can cover
yeah,
that very briefly.
yep,
If you have an iPhone right now, you participate in a federated learning system. So when you get your iPhone in the mail and you tell Apple, I don't want to share my data with you, Apple respects that. They don't pull your data from the phone. But what they do is they send you an AI model to your phone. And when you update your phone, your phone is literally training that model on your data. It also introduces noise into that training cycle so that it can obfuscate you even more. And then it sends the model back up to Apple. In that way, Apple can learn about the population behaviors so they can improve their products without exposing your data. So if anyone has an iPhone, you're doing it already. It's happening now. And you're right, like for individual patient records, yeah. I mean, like if an organization said, hey, do you mind sharing your patient records so we can improve services and prediction recommendation engines or whatever, and you said no, federated learning would be one way for your data privacy to be maintained, while the institution that really needs to improve their services could continue to improve their services. Yeah, I think that's really quite applicable.
yeah, awesome. One final question as we wrap up. Not the crystal ball question, because I think we all can sort of guess where it might go in 10 years, and 10 years is a long time, and the odds of being right is pretty low. I guess the question would be, what can people do today, tomorrow, next week, next month to start learning more, start looking at this journey, thinking about how they can adopt it and adopt it safely and improve patient outcomes?
I would say the first thing is internalize something you just said, Johan, which is internalize the idea that we don't need to be beholden to as a service systems, even if, especially if they're in another country that you don't particularly trust. We can build those same services locally. Okay. Like just because Microsoft has a really great offering, and it probably is really great, that doesn't necessarily mean you have to use it. You could reproduce a similar offering within your own private cloud, within your own enclave, if that's what you want to do. And I think the cost and technology barriers are actually a lot lower than you might think. Um, Now, shameless plug here, Red Hat, of course, is involved in a lot of that. So, like, we'd love to do that with you, but I'm just, just want to make it clear, like that's something that can happen. The second thing is get involved in the standards bodies. So like go join the BPM Plus Health Organization as it moves into HL7. If, like I said, you're already a part of that organization, then that means you have membership. You can go join those working groups right now. Um, or if you don't, most of those are free to the public. So and we actually have HL7 meetings in Australia frequently enough. So keep an eye out and go join those standards bodies. Maybe you'll see me there, um, and we can chat. So I just highly recommend get really familiar with the organizations that are engaged in defining the standards that we're all gonna really rely on for that healthcare revolution that I'm talking about. And I don't know, last but not least, I would say really internalize the idea that this revolution happens because of the learning health system. Start to think about ways in which we can accelerate the knowledge that is produced by researchers and how we can move that knowledge quickly into practice. I think that interstitial space between the new knowledge and the practice is where we're going to see the most value created. So maybe start to identify those paths and bring those to the open source community, and say, hey, I want to solve this particular problem for acceleration of knowledge to practice. Is there an open source community that already exists that's working on this? If not, maybe you should start one, or talk to an open source expert, like maybe somebody from Red Hat or the Linux Foundation or whatever, about producing that community, and then seeing how far that community can actually go.
Excellent. Yeah, Ben, thank you for your time, and thank you for everyone that joined the call. As Ben mentioned, yeah, please reach out, join the standards bodies. We're both on LinkedIn if you want to talk more and want to know more. And I certainly learn a lot out of the healthcare world, a lot of conversations that we have in IT, which is kind of ironic in a way, to help enterprises move faster, comes out of the organizational typology work that's come out of healthcare in terms of how to structure teams to be able to make decisions quickly and safely, and move quickly, which is really good. But yeah, with that, thank you for your time.
Thank you for having me. It was great. I'm gonna go to bed now because it's 11:30 here in Maine, in the States.
Yeah. Good luck with all the coffee you have to stay up.
Yeah. Yeah, if there's any additional questions or whatever, feel free to reach out to the organizers here. That'll probably get to me eventually, and Johan, we can hit you back if you got anything else you want to talk about with us.
Awesome.
Thank you all.
Excellent.